Good day, everyone. On behalf of the Analytics Computing and Complex Systems Laboratory, or the Access Lab, my name is Christopher Monterola, and I will be presenting the technology that we've developed focused on artificial intelligence for water management system. The title of this project is Enhanced Forecasting Model for Complex Water Supply Systems of the East Service Area of Metro Manila. This work was done in collaboration with the Philippines Department of Science and Technology under the Science for Chains and Cradle program in collaboration with our industry partner, the Manila Water. To properly contextualize this work, we go back to March 2019 when Metro Manila suffered one of its worst water shortages in decades. The region was short by about 150 million liters per day. To put that in perspective, this impacts about 600,000 of Metro Manila's residents, or roughly 8% of the total number of residents in Metro Manila, same size as that of Makati. Water shortage is one thing, but if there's over water in a dam, it might compromise its integrity and they have to release water that can cause flash flood killing lives. So balancing act is very critical for this particular problem. Thus, in order to mitigate this crisis in the future, we partnered with the Manila Water Company under the DOST Cradle program. Manila Water is one of the two concessionaires tapped by the government to operate the water utilities in the eastern Metro Manila and the nearby province of Rizal. The Metro Manila water supply system consists of three dams, the Angat Dam, the Ipo Dam, and the Mesa Dam. These dams supply over 90% of Metro Manila's water, covering about 16.5 million customers. It is used to produce 256,000 kilowatts of electricity and irrigates about 28,000 hectares of farmland in the nearby provinces. Because of the multi-purpose nature of these dams, proper water management is needed to ensure that all these stakeholders will receive equitable distribution of water supply. Our solution is, of course, to leverage the power of data. Data science is a clear driver for innovation and businesses and enterprises, and we have completed more than 74 projects with industries and various institutions to demonstrate this. It has been shown that with AI and ML used effectively in an organization, they will be able to outperform their competitors and deliver better service to their stakeholders. This project began in February 2020 with the team of the Access Laboratory at AIM and Manila Water working closely. As you all know, pandemic happened, but we are happy to say that by shifting our priorities and remaining agile, we were able to find new ways to communicate and collaborate. And I'm happy to present the results of this collaboration. Again, forecasting dam and water reservoir is a non-trivial problem. Building a robust forecasting model can be difficult as it involves modeling nonlinear interaction between complex systems. In this case, water levels are driven by supply factors such as weather, rainfall, and climate patterns, and also by demand factors such as irrigation demand for farming. Our model utilizes both this supply and demand side factors and is capable of generating accurate forecasts 1 year in advance. Why is this significant? Because if you have 1 year in advance forecast, then you can do intervention and maybe prevent flash floods or even water shortage from happening. I'm happy to report that this model consists of some of state-of-the-art deep learning models combined with traditional statistical methods performs 260% better than the EVE forecast with an MAE equivalent to 6.2 plus or minus 1.1 meters. The model is versatile. It can capture the changes in water level. Say, for example, there is a sudden spikes due to typhoon in the rainfall data. And it can be used for scenario modeling. For example, shown here in this figure are the different irrigation release. And we can forecast how this irrigation release will impact the Angat Dam water level. As an academic institution, part of our initiative is to ensure that the R&D that we develop is up to the international standard. We're happy to say that there are 3 international publications in very reputable journals that resulted in this work, and it's covered by these publications. As for the current status of the model, we are happy to say that it has been deployed and is currently operational at Manila Water's control system being used by the MANCOM. And they use this model to better prepare and plan for the upcoming summer season which is when we expect water levels to be at their lowest. Call to action, we want to say that with government, industry, and academia working together, we can more effectively address the country's most pressing challenges and deliver transformative change to the society. So in behalf of the team, thank you everyone for listening.